Howdy folks, welcome back to another video. The video you're watching or will watch here shortly is inspired by a viewer, Gino Askey, something or other. I'll put his YouTube handle right here. And this is kind of a redux or a redo, kind of revisitation of the Concourse 14 cam chain rattle video that was published in 2021. That video's almost got 55,000 views and a lot of comments. A lot of really good comments, but Gino put a comment up recently that had some really good questions and information in it, and it's the inspiration for me to do kind of an update. In this video we're actually going to do some machining. We're going to do some testing on that hydraulic cam chain tensioner from the Concourse, and we're going to try to really answer the question as to why it wouldn't do it on a new bike and it does it on bikes that have a little bit of mileage on them, and essentially, is it really something to worry about or is it really something not to worry about? That was the whole purpose of the original video. That's why I put relax, don't worry about it in the title there and also in the video. It's not a big deal. Well, I'm going to tell you right now at the end of this video, I think you're going to feel even more comfortable about it from the findings that we uncover in regards to the experimentations and so forth that we do in this video. Also, you'll notice that I'm on a webcam type of setup, and I want to ask you a favor. I need you to tell me in this video comments, would you like me to start doing Q&As and things like that? And that's why I have this equipment that I picked up not too long ago. I didn't think there was much interest, so I need to know in the comments if there is enough interest, and I'll start doing that. So that's about it. Again, thanks Gino. Your comment and others as well, thank you to other commenters as well, were the inspiration to this video to kind of update and redo this. So let's go ahead and go over Dad's old bench and we'll get started and move along with this video. Alright, so here we are again, talking about this cam chain tensioner. This is the one from the Concourse 14, which, as you well know, is a hydraulic cam chain tensioner because it's oil pressure actuated. There, of course, is a spring in here to keep it sprung outwards, but that spring really, it is a pretty stiff spring when you get the thing pushed in a little bit further. But really what it does is just keeps it pushed out. No different than other tensioners such as this one, which I did not have available, or I couldn't find it during the last video a couple of years ago. This is a ratchet style. It does have a spring at the end here, which is some sort of a damper, a much stiffer spring. But this is your ratchet style, where you can kind of release that ratchet, and if you hear it, hear how it ratchets. Now this style is relevant to our conversation because we're going to go right into the comments that Gino had written, because the first comment he writes right here, if you can see it, is someone pointed out that a cam chain tensioner could be stuck between ratcheting positions. That would be a relevant hypothesis if it was a tensioner like this, because you could easily have that situation. Now you see on this tensioner it has, let me zoom up a little bit more. This tensioner's got a rack and a pawl, so it just kind of goes into those little slots, and they're very close together. It wouldn't be unlike a ratchet, like a snap-on or something. It's got a very fine ratcheting mechanism in there. Usually that has like 2 or 3 pawls. This is just one, obviously, but the rack straight across machined, and it's got just very, very close distance between each one. So this thing only has to move a slight bit before it goes back in, or goes into rather, the next step, the next place, location. Now you'll notice though that once this thing clicks in to another location, this is all the movement you possibly have, which is really just a little bit of play here in the pawl. Once this thing is back against itself, it will not move. It is a solid lock. So this is really only a one-way job. And I brought this up on the original video. That is not the case with a Concourse 14 hydraulic cam chain tensioner. It's not the case, because if I release this one a little bit to push it in, that's not the easiest thing to do, because this thing is actually, this spring is actually pretty stout. If you have it set up like this, and this is all the way back now, that clip is the same as this pawl in this application or this example. So this thing only goes back so far. Now if you let this thing click, and I showed you this in the first video, just click, so it's advancing to the next one. Now it's in the next slot. look at the distance you have between the next slot, or in other words, it's trying to click into the next one and all the way back. That's because this one doesn't ride all the way back. This style does. This style does not. It can't. Because once it clicks over, I would consider this clip and this stop doing this as a fail-safe, as a backup. So it can't come all the way back. It is not, I repeat, not, in my opinion, the primary locking mechanism for this type of a tensioner. The primary locking mechanism is the hydraulic pressure. This is more of a fail-safe. This thing guaranteed does not ride all the way back here. It can't. It's got to ride up in here somewhere. So if it clicked over again, you see it just clicked. See how much you can go backwards before it stops. So this does not ride back here. I believe we have to get out of the mindset that this is just like this one when it's set up like that. I do not believe that that is the case. So let's move on from there. So I would say that the first statement is not going to be relevant. It's a great point, but it's not going to be relevant because it's a different tensioner. If it was a tensioner like this, I'd say absolutely. And maybe the tensioner is at its maximum throw because of the cam chain elongating, stretching, wearing, whatever your belief is, because there's a lot of controversy over that, depending on where you read it. Or maybe not. You know, maybe the tensioner's got a problem in itself. But it's not the same as this one, so that's not going to work. That explanation really can't be applicable to this tensioner. Another user put a very relevant question I think will help explain this and also illustrate the differences between this type and the hydraulic type that we're covering at this point. So he said he has a 2001 Yamaha R6. He said a while back he noticed a noise, top end noise, and so he took the oil plug out, and when he ran it, you could hear like a clackety-clack sound, looked like it was coming directly from the cam chain. So I'm not 100% familiar with that model, so I looked it up in the parts fish, and indeed the cam chain is on the right side of the engine, just like it is on a concourse. In other words, it's not in the center of the crank, and thus the center of the cams like it is like on an OKZ 1000. So that's right where the tensioner is too, on the right side of the motor. I'm assuming the clutch would be there as well, and so therefore you can definitely be very close to this tensioner when you take that that bung plug, if you will, out for filling the oil up on the clutch cover. So he said what he did was, what somebody told him to do, was to put it in 6th gear and roll it back and forth and pop the clutch going backwards, pop the clutch going forwards, and do it a few times. And he said that worked. He said the noise went away, and all he has is the normal tick-tick of the top end, and he wanted to know why that worked. So again, I'm not familiar with the bike itself, so I've never worked on one, so I looked it up in the parts fish. I can't really tell from the tensioner whether or not, I'm pretty sure I got the right model, whether that tensioner is a ratchet type. It doesn't really look anything like this, but it doesn't look like a hydraulic one either. So I'm assuming it's either a ratchet or some sort of a friction one-way thing. Either way, this is the reason. Now, what he ended up doing was, you have to picture the fact that the tensioner is on the slack side of the chain. When in an engine like that, and we'll show you a little B-roll of the drawing on the service manual of the concourse, you can see the cams, and you can see the cam chain. Well, most likely that one turns in a clockwise rotation because the tensioner is on the back side, the slack side. So the crank is actually pulling the cam chain down from the exhaust cam down. It's pulling it, and then on the other side it kind of, for lack of a better description, it kind of pushes it, you know, as it goes back around, but it's pulling it. The fixed side is the tension side, so it's always under tension because that's the way the thing is rotating and pulling it. And remember, there is a certain amount of force it takes to move those valves against the buckets and so forth. So it's definitely in a state of tension on that right side or the front side. So that's why they put the tensioner on the back side. It wouldn't make any sense to put it on the tension side. It needs to be on the slack side. So what he most likely did was, let's say it was this kind of tensioner was sitting right about here. Now, if that thing was just about ready to go click like this, and it had a little bit of play in it still, if he went backwards and he popped the clutch, he kind of forced that chain on the slack side to go a little bit more slack and allowed it to go click into the next spot, which is perfectly fine because it would eventually find that anyway. and then it took up just that little bit of play and his noise went away. I'm not exactly sure which way did it, but that is essentially what happened. That's what I would say is what happened. Now, this is not uncommon from what I do when I put these engines back together that have these kind of cam chain tensioners, whether it's one of these or the Concourse, I'm sorry, the old KZ1000s and so forth that have the two tapered kind of wedge style. And pretty much all of them, what you can do with this, with the exception of a hydraulic type like this, is you put this thing in, and I just bar the motor backwards after I let this tensioner come up to where it wants to go. So I would bar the motor over in this normal rotation direction, clockwise for example, and then I just a little bit move it backwards against the starter clutch rather, you know, that sprag clutch, and just, you know, it's not going to hurt nothing. You just go a little bit backwards, and what that'll do is it'll do the same thing. It'll slacken the tensioner side and possibly allow that to go to its absolute final setting, and then it's done. So I believe that's what he did, and it was a really good question and relevant to what we're talking about here. So I kind of wanted to mention it at this point. So his question and the answer I just gave you segues perfectly with the next section, because we're going to go over the differences in the hydraulic cam chain tensioner. We're going to take a look at the cam chain and the tensioner setup in the service manual drawing for the Concourse 14 to kind of give you a little bit more information and background about the differences between this type and the hydraulic type before we move on to other stuff and testing. So here is a drawing of that side of the engine, the right side of the engine on a Concourse. And of course right here you have, let me get a better pointer. Right here you have your intake cam, this is your exhaust cam. The Concourse 14, as we identified in the original video, and I've talked about it before, has variable valve timing on the intake cam. I'm not really sure what the strategy for that is. I do know that when, according to the manual, when it's at idle, and I'm assuming at cranking at startup because you're at idle as far as the TPS is concerned, the cam is in fully retarded position. That may have some relevance to us later on. It may not. We may or may not come back to that concept. This, of course, is the tensioner that is in the this drawing, which not necessarily to scale, but you can see the tensioner pushing against the movable side of the cam chain guides. So this is the guide on the movable side, and over here is your guide on the stationary side. And if you recall, just really briefly to rehash that, what I said in the original video, and I do believe this is the case still, is because this is slackened off and you first start it up before the oil pressure pushes it. I think it's not totally slacked off, but enough for it to rattle around with the chain against the guides. This is not the chain rubbing against any aluminum. This is the chain against the guides. That's what you're hearing, okay? And we're going to really prove this out, I think, under testing. But it is my theory at this point that this thing is not completely backed off, because it has some pressure on it. It just doesn't have enough pressure to take up that rattle. Gino hypothesizes, and I don't quite understand his wording here, but I think what he's saying is cam chain could have changed in length. I think what he means is the chain elongating, stretching, wearing, whatever your belief is, so far that it's extending past the furthest amount that this tensioner can come out. I don't believe that that's the case. I don't believe that that's the case at all. If that was the case, it would rattle all the time, because when it starts up and it gets oil pressure, this comes out, puts pressure on that movable guide, tightens the chain up, Bob's your uncle, it's done. And I don't believe that that's the case at all. So this thing is certainly within its range of extension when it's in use. Otherwise, again, it'd be rattling all the time because it can't put enough pressure onto the cam chain. This is kind of relevant to what we're going to be testing. This thing can only be able to put so much pressure on the chain. If it put too much pressure on the chain, it could damage it. So it's designed to only put so much pressure on that thing and no more. That's one of the reasons why I thought about testing this. Because here's where the oil goes in. The oil, you would think, you might think to yourself, well, it's like a hydraulic cylinder and the oil goes in but doesn't come out, and it generates movement on a piston at some point in that cylinder. Well, that's not the case. The oil will come out through it. This is not a seal in there. It's just, one into the other, and it does have a little bit of play. So it's designed to essentially have a certain amount of flow. So that keeps this thing lubricated, and the oil goes in and eventually comes out this way. We're gonna see that too. We're gonna see how that works by putting this under pressure, just like it would be if it was mounted in the cylinder head or cylinder block in our case, I think. So I don't believe that that's the case either. I don't believe that this is rattling because it's at the end of its useful range. Otherwise, like I said, it'd be rattling all the time. But it is a good point, so I don't think that's the case at all. So Gino also brings up a really good point down in here, and I think this is part of what he was writing up here. The chain, he's talking about chain stretching. I think what he means is if you have a certain amount of stretch or the elongation in a cam chain, all right, and then let's see if we can draw it out here real quick, if I can find a pen. So it really depends on your school of thought. I tried a drawing here, it doesn't work. Can't really see it. On what happens with a cam chain. I think what he's saying is that if you have a cam chain that has elongated, gotten longer, this point here to here to here to here, and it's greater than the spaces it's supposed to be falling into in the cam gear, then it can be riding on those high spots and maybe making those noises as it kind of drops in, when it finally drops in somewhere. Now that's possible, but I've never seen it myself before. And it really depends on your scope of understanding or belief on what happens with overhead cam chains. I have read some people who vigorously deny that these chains actually stretch. They say that they wear, like the pins wear, but they can't physically stretch. And the cams, the gears themselves might wear. Now I don't believe that one bit. I believe that these absolutely can elongate and stretch, and evidence of that is certain manufacturers will give you a standard in the service manual to count a certain number of pins and make a measurement across that distance to see if it has stretched. You don't do it between 1 or 2 pins. It's usually like 5 or 6 or 8 or 10 pins. And as far as the cam chain goes, and if it exceeds that amount, the cam chain needs to be replaced because it's stretched out. So this definitely is a factor as far as cam chain stretch that would require an automatic cam chain tensioner, because otherwise why would you need one in the first place? If these didn't stretch, if this didn't wear, if this didn't wear, then why would you need a cam chain tensioner? Just put it on with the cams, put the cams on with the sprockets, make it nice and tight. You never have to touch it again. Obviously, stuff wears and stuff does stretch as far as these chains go. So that's why you need different types of tensioners depending on the application. Now, I will reassert my hypothesis right now that I said in the first video. I believe that this tensioner, being a hydraulic tensioner, is specifically designed to be in circuit here because of the variable cam timing on the intake cam. This variable valve timing. Because this, I don't know how aggressive it is, I don't know how fast it moves, but because this thing is changing its attitude, there has to be, there's got to be some sort of shock load, if you will, or some sort of changes in the tension on the chain based upon where these lobes are articulating with the lifter cams, the buckets. There has to be some sort of change in the tension from that. At a given RPM, at a given advance or retardation of this particular actuator here. My hypothesis is that it has a hydraulic cam chain tensioner for that reason. Because there is going to be some variance in the stresses on this chain. I can't think that there wouldn't be. So that's got to change the dynamics of this, I would imagine, when this thing is actuated. And that's when I believe they have a hydraulic tensioner in place. Anyway, let us go machine us up a fixture that we can pressurize this tensioner and test it and see exactly what the heck it's doing. Outside diameter of this thing in imperial, if I can get my mic on it, is I want to make this super close, like a really tight fit, like the bore inside the cylinder head is where this thing fits. There's no O-ring or anything inside there that seals it off. It's just aluminum to aluminum. So we'll kind of duplicate that. 865 in imperial, so 865 thou. That's what we're going to shoot for. I used the caliper to get us close, but like I said, I want to get this pretty tight fit, snug fit. So I'm going to get a snap gauge for this too, so we can mic it up a little bit closer, but we'll just ultimately use the tensioner as a go, no-go for it. This is at 777 thou, which is kind of interesting. 777. So 40. Actually, let's back off to 38. That's in case. It shows 852, so we're pretty close to where the DRO says it's supposed to be. This time we won't drag the tool through it, because we're getting real close. Ah, dang, I'm going too fast on my feed too. I gotta slow that down, the final cut. Oh yeah, like 2 thou away, maybe 1.5. So it's gotta be about 1/2 thou big, maybe 3/4 of a thou. So what we'll do is, let's drop some. Let's drop the damn WD-40 can, why not? We'll add nothing, we'll do a spring pass at a slower feed rate, 0, where it was. Try that. I gotta keep sliding you back here because I don't have room for the boring bar without hitting the tailstock quill. So that's why you're there. Oh, yeah, that's much better. God, strangely satisfying. Let's see. I bet you we're going to be really, really close. I mean, we're not reinventing the wheel here or going to the moon or it's going to pass an inspection from somebody who actually knows what the F they're doing. We want it pretty good because I want to duplicate this test as it would be if it was inside the engine. So we're getting real close. I'm going to finish this rest off camera and then come back when we can slip it in. This is going great today. It's a little tight, said the wife, but it's tight toward the back where that little hole is for the pressurization. I'm not going to worry about that. I'm just going to take it out by hand with, I'm just going to give it a hand job, you know, with some sandpaper, and we'll make it fit that way. So it's going to go only one way. Doesn't need to go 2 ways. And I think what I'm going to do here, because this on the engine has a regular gasket where this thing sits. Well, I'm going to put a little O-ring groove on the inside here, but not so far up where it's going to... So, well, actually, no, I'm not going to do that. Stop the presses. I think I was thinking about this before and I already came up with a solution. No, we're not going to do that. We're going to use the compound and put a chamfer on this outside here. I'm not going to show that. It's just really simple shit. Just a little chamfer on the outside here. About 45 degree. Right now it's set for 45. I thought it was set for 29 and a half. So we're set for 45. We'll put a 45 degree chamfer of a certain width, and then it'll just allow clearance for just some thin O-ring that can dig up. That way we're obviously going to put 2 holes in the end here, and then put some sort of a hole in it for a fitting. But those will all be clocked properly so they line up. So the fitting hole is going to line up with this one just like it does in the block. And then this O-ring on the back, rather, because I can't speak today. I need an MRI. That'll just be a little bit bigger, so it'll seal off that little corner there, kind of like a gasket would. That'll be fine. So I'll do all that off camera. I don't think we can get too much better than that. I'm not sure about the chamfer yet. I'm going to play with that again off camera, but I want to show you how well this thing fit. Perfect. And I'll do that thing for the O-ring, like I said. Got a little bit of it going on right there, but I'm not sure yet. Anyway, just wanted to show you that. You know, I could have sworn I had an old piece of brake line with 2 banjos, one at each end. I could have sworn I did, and I know I did. Probably in the dump now. So now I got to modify a piece of hose that's got 1 banjo and a fitting on the other end, and change this over to whatever the hell it is, to M10125. Side project time. Don't you just love it when you leave crap on the other side of the workshop that you need on this side? Yay! This anchor lube comes out like you're squeezing a freaking zit, I swear to God. Sometimes it's very frustrating. Yeah, it's close enough for government work. This could go poorly. I do not have a tailstock die holder to fit this lathe. The one I have is an MT1. This is an Morse Taper 3. I could single point these even up to a shoulder like this. There is a way to do it, but I'm not going to change the change gears around just for one freaking thread. So we'll put her down slow to 70 RPM and just bump it. This is M10 1.25 thread pitch, by the way. It's pretty standard for brake banjos on metric bikes. Now what we'll do is back that out. Haha! I'll go over to the vise, spin this or tap around, this die around in this die holder, and get right up to that flat. I could always cut a little thread relief in. I think I'll do that before I do that. Yeah, I'll just put the threading tool in. So that's what we'll do. I'll do that off camera. All right, that hose worked out pretty well. I'll show it to you later because got to get moving. That was a side project anyway. When it comes, oh, I took a drink of water and now I'm choking to death. We'll show it to you later when we go to put this test rig together. I know I'm being a little elusive on this because I don't really know. As I'm going through, I'm kind of figuring stuff out. I'm not trying to be, but you'll see when we get it all together. So anyway, we're going to drill and tap for another M10, I need an MRI, an M10 1.25 with a small hole for the oil to go through into that bore, which is going to line up with the hole, the oil hole on the tensioner. All right, you see on the tensioner there, the oil hole, which is actually kind of at an angle down that way, but you have this relief here. I measured that out, and with that 45-degree taper, or angle I should say, chamfer on the other side for the O-ring that's sitting right here. It's about 3/4 of the way through that bore, the edge of this relief for the oil. So if we go to the center of the part over here, we just go to the center of the part and do the deed with a small hole. The small hole is probably going to end up about right here into this relief. Let's get you in frame. Right here into this relief, so that's going to feed directly into that oil hole. So we're just going to go to the center and say screw it. That's going to be close enough. And we'll just eyeball the size of that hole. I'm not really sure the size it's inside the motor on the engine block side. You know, it's comparable to that. So we're just going to use that as a guide when we drill that. So let's find the center X and Y first. I'll do that in time warp. Okay, all standard stuff, so I'm going to do this also in time warp. I'll show you up close later, but I ended up using an end mill that I had, luckily the right size. Flatten that hole. I need the biggest depth I can. I used a number 33, I believe it is, drill bit to penetrate down through into the bore, which is about the size that's on that tensioner. And that wall is very thin, maybe 50 thou, which doesn't need to be thick. I need the depth here for a thread. So beauty of the DRO is I moved it all around to mill this flat. Obviously, I don't think I need to explain this, but obviously I need a flat for the sealing washer on the banjo. So now we're just going to come back to 0 and chamfer it and get a tap in here. And I do have a very short, well that too, I do have a very short banjo bolt. I don't know what it came from, but I pulled it out of my banjo drawer. Going to use that one. M10 125, but let's just chamfer it really quick, lightly. Give it a light chamfer. I just don't want to lose a lot around there. I'm going to lose a little bit from the thread, but anyway, I'm going to try to power tap it in, but I'm going to get it started. And I know I have an M10 bottom tap as well, so you've seen me tap before. I'm not going to worry about doing this part on camera. All right, folks, here's the fixture bolted up to the tensioner. You can see what we're going to use it for is obviously to pressurize the tensioner. It'll make a lot more sense when we go to do the testing that I have in mind. So we'll just leave it for that. But right now I'm going to go do some other stuff and then we'll come back when we want to do that testing. All right, let's go over to test rig. So this is what you see me make just now, but I did some modifications to it, mostly off camera. I did a couple of quick B-roll clips to tap into the pressure port here that's going to go to the banjo from our pump, and I'll show you that here in a second. So we can just tap into it like this, because the hose that comes with the oil pressure test rig that I got is about 3 miles long. I didn't see the need to have that kind of a mess going on. So what that's going to do is it's going to go right inside our pressure rig, which I'm going to show you in some B-roll as far as that front brake master cylinder goes. So that's what we're going to use to provide some pressure. Not going to be super real world, but it'll work at least somewhat. So we load our, I almost said caliper, geez. We load our tensioner up with the pressure port facing this port. I have this clocked in such a manner where on the chamfer side here, when you put it in, that O-ring goes up and just seats into the chamfer and my holes are still in alignment. I don't know where I was. I always get pulled away by something. So anyway, we're going to bolt this together just with some M6 bolts. Now remember, I said that this does not seal off inside where it mounts in the engine. It just sticks in there. You install it with the clip upright like this, and that puts the pressure port to the left, and that's where the hole is, where it lines up to in the engine to feed this thing. So now it's a matter of just taking this banjo. I'm going to thread it into the pressure device here. The, I don't know what you want to call it, besides a complete mess. We're going to thread it into the master cylinder deal with a couple of banjo washers. Well, actually, it's only one because it's going into a, a flat surface, a port. And if these banjos leak a little bit, I'm not going to be too terribly upset about it. This is just a kind of a reference test. It probably won't work anyway, but I'm interested to see what it's going to do. So let me go get some motor oil. We're going to put motor oil in this and bleed this thing up. Yeah, I can feel it generating some pressure, but we got to get it bled. There we go. I'm getting something now. Feel it. Like we do on brakes, I need to bleed this master up separately. It's bleeding up just fine, even with this motor oil, believe it or not. Well, believe it or not, this is actually starting to work. We're able to get some pressure built up. What I ended up doing was I made a check valve part of the banjo bolt. I kind of turned it into a check valve. Ow, that hurts. And put a ball and a spring in it. It builds up pressure and then it loses it, but it's getting close to at least 30. But I can tell you right now that even when it gets close to that pressure, it's still not all that hard as far as the piston goes here. And of course, as I suspected before, this is just pouring oil out this thing because it's not a true seal. It's designed for constant pressure, not for static pressure, momentary, of course, for flow. I can get it and then it loses it. It could be in the master cylinder itself. This thing just needs a rebuild. Of course, I'm using it for something that it's absolutely not designed for. All right, this is interesting. If I pump this piston to the limits I can before it hits that clip, I can get it pumped up pretty good. I mean, I just did. Now, watch, it won't let me do it. But I got it up over 30. There we go. There we go, 30, 40. And I can still move that. In other words, it's not rock solid. 40, I can feel it trying to push my hand out, but now we're almost up to 50. See how it's holding? Then it drops down because the oil's coming out of here. But I can definitely hold that, and I can definitely push it in even further. And when it tries to push me out, in other words, push my hand out, my palm, which is not the most comfortable thing over here, I want to tell you that. I can push against it, see? So this is a properly properly malfunctioning, yeah. This is a properly functioning cam chain tensioner. There wasn't anything wrong with it. I just replaced it because I wasn't sure what the hell was going on with that noise originally when I originally had the noise come up. So this is very interesting. And there's really no air in there, maybe a slight amount, but this is oil coming out of it. So that little check valve is holding it enough where we can get an idea on what's going on with it, which I thought was pretty interesting. Yeah, so let's do this again. Just got to hold a rag on it because it's killing my hand. And I can try to keep it in frame. This is not the easiest thing to do, folks. I'm telling you right now, it just isn't. I'm doing the best I can, but it frustrates the hell out of me when the damn thing, stupid thing's getting away or it hits. So we're up 25. I can feel it pushing my hand out, but it's not pushing that hard. We're like almost 35, 40. Got up to 50 before. So like I said, I can push that in and out right now a little bit. And you hear it just kind of bleed out, bleed the excess pressure. And again, where the pressure is coming from is here. Like I said before a couple times now, this is not a perfect seal. So there's, dynamic fluid pressure going in here that is controlled by the oil pump, and the pressure relief valve on the oil pump, or I should say the regulator, and excess oil just comes out of here. So this needs a constant flow to do that, and I can't find any indication of any ECU control for oil pressure. So, I mean, it'll tell you what the oil pressure is, but as far as a change in the pressure, the only thing that's going to do that is RPM, engine RPM. So there you go, look at that, we're almost up to 50. And I can move it. It's pretty firm, but it's not rock solid. It's not rock solid. Now, if I put constant 50 PSI into it, I don't know if it'll be much different because I'm pulsing it to that level. We're getting up to that level, and like I said, we're almost at 50, and I can move this thing, see? So I think that's enough testing to really make a call that this is not a device that comes out under pressure and locks solid. And I suspected it wasn't because of the variable valve timing. Why would you want to have something like this? Where is it? Why would you want to have something like this that ratchets and locks in place when you have, I think, some dynamic tension changes on the cam chain because of the variable valve timing? I believe that's why they use a hydraulic actuated cam chain tensioner, and I believe it's designed to fluctuate and be able to kind of cushion, like damper, more like a damper device, damper any changes to the tension. And as a result, one of the side effects is it bleeds down, and when you start up the engine, it has to repressurize it to come up to nominal tension. So this section right here, assuming that this is pushed in and it's resting in its normal resting position, let's see if we can do that. So let's say it's about right there normally, and when the engine turns off, this is going to get a little soft, so it's going to want to go back in. So if it's in this range right here, between where this clip is back there, where it's not going to rest there, it's just not gonna, it can't be designed to do that, it's got to fluctuate. This thing has basically got to do this. The way I'm seeing this, under normal operating conditions, this has got to fluctuate a little bit. That's why there's so much play right here between bottomed out and clicky click. And that's just a fail-safe to keep it from going back in all the way. I think this test really proves this, because we're getting it up to pressure, and this thing is not rock solid like a hydraulic rod, on a hydraulic cylinder with some sort of a one-way or a spool valve or something, of course, to keep it in that position. But yeah, I think we pretty much proved that with this test. And I suspected this all along. I suspected that this was not a device that just comes out and locks in. I think everybody's got, where is it? I think everybody's got this on the brain. That's the problem. Everybody's got this on the brain. They got the latching, ratchet. This is what they got on the brain. You got to get your brain away from this and think about it from a dynamic point of view, that you do have to have some fluctuations, some variance in dampening in this because of the variable valve timing. And as a unfortunate side effect to this is the fact that when it bleeds down, it's got to be pressurized back up. Now, why it doesn't do it on a brand new bike? Maybe it does and we don't notice it, I don't know. We'll close this video out and kind of make a quick discussion on that. Well, on that line of why does it do it or not do it on a newer bike, and do it, allegedly not do it on a newer bike and do it on an older one, or one that's got a little bit of wear on it. And I think that is explainable with the tensioner itself. There is most definitely a range that gets progressively harder to push this in the further it goes in, and that kind of makes sense, because springs, like a little progressive spring, for example, might be easier at the end of its run than it would be closer toward when it's fully compressed or mostly compressed. Now, I'm not saying this is some fancy progressive spring, but naturally as the spring gets compressed, it gets tighter and tighter and harder to compress. The other thing I noticed was I had an easier time getting this thing to develop pressure on my gauge here when this thing was further in. These clips are a real pain in the ass. They really are a pain in the ass. I wish it was a different type of clip, but unfortunately it's not. So we're going to try to get this thing where I can get this thing in a little bit further, but it may not let me do that because it's such, there it goes. We got one more notch out of it. All right, so when this thing's further in, let's say when you first bought the bike, this tensioner was way back in here. This is markedly easier, harder rather, to keep in than it is when it's out. In fact, it's killing my thumb. I'm going to have to move around here. I'm going to have to redo this. It's killing my thumb. So let me reset this. I mean, my hands are already shot from showing you on this video holding this thing. I got no other way to clamp it, though, dynamically to clamp it. Up in there, it's really hard to keep compressed. We add some pressure to it. it's a lot easier to develop pressure on that gauge. I know you can't see it, but it's a lot easier for me to get pressure in that gauge when this thing is in versus out this way, because of course there's no seal here and there's more of that piston inside this cylinder. So there's more surface area. Ergo, it's probably going to hold pressure a little bit better. Plus, it's got a stronger spring tension when it's in that far. I believe that that is probably the explanation in itself right there. When everything's tight and the chain is new, it's not stretched out, not elongated at all, nowhere to the, or nowhere at all rather, to the guides. This thing is further up inside here, is putting more spring pressure because it is further up, and it develops pressure, if not holds it better, because it's further up in this bore. So when we get some wear and everything starts to relax and this thing comes out a little further, maybe around here, there's less of it in the bore, more oil essentially can get by, plus the spring tension isn't as much. Now it's still going to operate fine because of the pressure. You know, it's still going to operate. Like right now I'm having a hard time. I'm up to about 25 psi, having a hard time holding it in. Of course my hands are tired as hell from doing this. It's hard to see because I don't have a very good swivel setup here. I don't have any swivel setup. If we do it this way, we can bump it back up. We're at almost 30 psi here, 40. And when it's out that far, when it's out about here, it's not exerting a ton of pressure because the piston's not as far out, or far in rather. That's my theory at least. And again, the spring tension is not as great. The inherent spring tension built into this thing. I think those are your reasons. So the net sum is, I don't believe that there's anything wrong with these. It is just the nature of the beast. So the answer, really, the real answer then for my friend Gino here is, bottom line, these engines should not be making any noise. I would have to disagree with him. I would think that in this case, and perhaps other bikes that have hydraulic tensioners like this, same situation is gonna present itself over time. That's just my feeling, based upon all this testing and everything else, and seeing the damn thing when the engine's apart doing the valves, of course. So I'm calling it as, there's nothing wrong with these, it's just the way it is. All right, so that's it. I know what I'm going to hear too. I know I'm going to get comments from, oh, I'm a Concours 14 owner. I own a whatever, 2010, 2009, 2011, and it's got 80,000 miles on it, and it's never made one startup cam chain rattle, nor does it do it now. And so, why is that? And the answer is, I don't know. All I know is that certain bikes, even within the same model and same model year, do different things. My C14, my 2012, has had a clutch howl since day one. A howling clutch when you get on it in the friction zone, like a hard pull essentially in the friction zone. Howls like a son of a bitch, especially when it's hot. I brought it back to the dealer when it was new. They said they reached out to the mothership. The mothership said it's just the way it is. Some of them do it. I've researched it on forums before, and I do find some hits, albeit not many, on ZX14 forums with the same kind of clutch howl, just like you probably have done if you researched cam chain rattle on a Concours 14, which probably originally rather, brought you to the video, the first video we did on this, and maybe even to this one. So the thing is, it just happens. I don't know the answer to that. All I do know is, based on this testing, and based on what I found, I'm sticking with that working theory that this is just one of these things, and it happens after everything wears in and stretches a little bit, and there's nothing to worry about. So like I said in the first video, relax, go ride. Oil changes, maintenance, flushing your brake fluid, tire pressures, all that crap is way more important than worrying about rattling cam chain at startup. Now that we know what we know about this thing. Think about it that way. Don't worry about that. Worry about the important stuff, because this sure as hell ain't that important in the scheme of things, all right? You got a constant rattle or knock, start worrying. But if you just got a startup cam chain rattle in a Concours 14, move on with life, go ride, have a good time, and kiss your dog, hug your wife, and then everything's good in the world. So if you want to see more stuff like this, then definitely consider sticking around. Subscribe, like, share it with Aunt Tilly, share it with your friends. Ring the bell, you get notified when I put more crap like this up. Why am I doing that? So with that, I want to say thanks again to Gino for putting that comment in, and of course anybody else who comments. It was the inspiration for kind of springboarding this video, so to speak, and making me think about doing a kind of an update on it, which I'm glad I did because it was a lot of fun. And also remember, put in the comments about whether or not you want me to do these live streams that I suggested or brought up earlier. If you want me to start doing live streams and Q&As is what I'm trying to say. I think I need a CAT scan, I tell you what. All right, so I'm going to go check on that CAT scan. We'll catch you on next video, of course. As always, don't just repair, restore. Thanks for watching. We'll see you then. Hey Alexa, what do you think of that video that I just uploaded to my YouTube channel?
I think it was the dumbest thing I've ever seen. I wish I could unsee it, and I'm dumber for it for seeing it.
Well, that wasn't very nice. Thanks a lot.
You're welcome.